Okay. Can you hear me?
Yes.
Okay. So, let's see. どうしようかな。one moment. So, I would like to explain about the bilinear hysteresis. Let's see. Do this one. So, okay. So, how to say? これねこれか。So this is a viscoelastic damper. Okay. And in case of viscoplastic, I mean, combined with friction damper, we assume this spring, connection spring, KD. This spring is a combination of elastic element and friction damper. So it's a bilinear hysteresis. Okay. So how to say? So we need this UK displacement of connection damper. So UK will be the displacement of bilinear hysteresis. Okay? So どうしようかな。あ、やっぱりね。I will change my screen. Can you see my handwriting?
Yes.
Can you see?
Yes. 大丈夫です。
I cannot hear you.
Hello?
Can you
hear?
see my handwriting?
Yes, sensei.
Yes. Oh, good.
Okay.
Okay. So, so bilinear hysteresis, when you, how to say, so start with here, 0. And one step, you check hysteresis, this initial stiffness. Okay? One step. Gradually, you increase deformation. And if it reach here the deformation dy, you will go to second slope. Okay? So first slope is 1, second slope is 2. So we call level. Level is starting from 1 and 2. Okay? And this increment, well, actually, this is, maybe I should write this part. So, this is UK. Okay? So what you need is delta UK. So when you look at this document, so you will get to increment of damper, this UC, from equation 8. Equation 8 is previous, this one. Okay? After you get delta UC, you can get you can get UC from equation 7, and you can get the force of, well, actually, force is common for all springs. It's connected in series. So you can get the force of this viscoelastic damper by this formula. But before calculating force in this step number 3, evaluate UK from delta Uij minus delta UC from equation 2. So let's see. After you get to delta C, and you already know Uij. Yeah. So delta, maybe I should write here. Delta Uij is Uij minus previous step E minus. So you already know the increment of viscoelastic damper. So if you substitute delta UC, you will get delta UK. Okay. You already know. Okay, I will go back to this one. So the document I sent to you is this one, linear hysteresis. Okay, I will explain this one. So, so D is UK. Okay? So DD is delta UK. And F is the force. And the DF is the incremental of force. Okay? So, なんでこんな色になっちゃうのかな。お、よし。OK。Sorry, it's written in Fortran, but actually algorithm is maybe same. Okay, so let's go. This is D. And okay, so this is D. And the increment is DD. The new deformation is D1. Okay. So first line D1 is equal to D plus DD. Okay. And F, and the new force is F1. And this slope is stiffness is S. So this part is S multiply DD, right? So the second line, F1 is F plus DDS. Okay. Then this slope, let's see. This slope is level 1. So this go to command goes to line 1, 2, 3, 4. Okay, depending on the level. If level equal 1, you will jump to line 1, line 100. So this line 100 here. Okay? If level is 2, you jump to here. Okay. So now we are starting from 1. So let's go to 100. So you will check D1 and dy, compare. So suppose dy is here. 待ってよ。OK. Already dy is here. So d1 is larger than dy. So in this case, dy is larger than dy. So you go to next line. Okay? And then you check the sign of dy. This is negative, 0, positive. Okay? So in this case, dy is positive. It's positive, larger than 0. So in this case, you jump to 120. 120 here. So if dy is here, fy is here. And it must go to next slope 2. But as you can see, well, this is D, and this is okay. So this part is over the hysteresis. So you must find the position of this position. This position. So it's a little bit larger than Fy. So F1 is not here. It's wrong because it's over. So Fy is actually Fy. F1 is Fy plus this second slope. Second slope is Sy. Second slope is this slope is Sy. So this second slope multiply B1 minus Dy. Understand? I'm talking about this deformation. This deformation is dy minus dy. Multiply this slope, second slope. It will be new force. This is the most important part of this. It's this. Okay, so this equation. New force is deformation multiply stiffness plus Fy. Okay, you understand? And the DCMP, what is DCMP? This is well, cumulative plastic deformation. So sometimes we need this value for, to calculate some kind of fatigue. We need a なんだろう、サメンジョン of plastic deformation. The plastic deformation is which part? Which part? Yeah, this part. This part is plastic deformation, right? This part. More than yielding. So DCMP, it starts from 0, and you add this plastic deformation. Okay? So you gradually, it will increase. So let's go to negative side. Okay, so you are now, D is here, and dy is here. Actually, this is minus dy here. And if your new deformation is dy, d1 is here. ちょっとこれ分かりづらいかな。So this is a slope, but you go up. So it means d1 is less than dy. Less than dy. So it means absolute d1 is, if you get the absolute d1 is more than dy. So you will go to second line, and d1 is negative in this case. So you go to jump to 110. 110 is this line. So what this line explains is to get the shear force over here and the force over here. So this point is Fy, minus Fy. A little bit smaller. Okay? So it's the same concept. So this deformation is this deformation is d1. Actually, this is negative. あ、これなんかおかしいか。いいのか。negative. And, いいのか。d1 マイナスだね。だから d1 マイナス d1. This is the deformation here. Multiply sy, second slope, minus fy. So this will be new force. So if you look at this formula, d1 plus dy, first one, multiply sy, stiffness, second slope of stiffness, minus fy. So it will be new force. And cumulative plastic deformation of negative side. So this n is negative side. Another one was positive. This one is negative. And this is a negative deformation. Okay, and this slope is, we put number 3. This is number 2, positive side. Negative side, number 3. Okay? So this is, I explained here. If new deformation is over than dy, it will 120. Okay? And if new deformation is less than minus dy, it will be 110. Okay? And new level number is 2 and 3. Now, suppose you are now level 2. So, okay. So, なんて言ったらいいのかな。Okay, you are now level 2. I mean, this is a subroutine. So every small step you call this subroutine. And every small step you check stiffness and change of stiffness. And now you are level 2. So you jump to 200. Jump to 200. Then what you should check is it continue to plastic going to right side, or it will return, coming back? How do you check coming back?
maximum cost.
So if DD is negative, so increment of deformation is negative, it means you are now level 2. Okay? So if increment is positive, you continue to stay level 2. But if DD is increment of deformation is negative, it will be coming back, return slope. Okay? So in this case, yeah, this is yeah, you should go to 210. Okay? And this return point we name DCRP. DCRP is critical displacement on level 3. Sorry, I made a mistake. This must be level 4. This must be level 4. Okay. So return slope we call level 4. The positive side we name DCRP, and the force is FCRP. And the left side we call negative side, DCRN and FCRN. Okay? How to get this displacement? Okay? It's easy. Okay? Always, the distance between two deformations, this one, is twice of dy. You understand? Yeah, I will write down here. Yeah. This is binary hysteresis. So if you continue like this, okay? And the binary hysteresis is going like this. Okay? Always on this line between these two lines. And always this deformation is same as this deformation. You know, this one is dy, and this point is minus dy. So always this, distance is 2dy, 2dy. So always this distance is 2dy. Okay? And always this force is 2fy. Okay? So you use this relationship. So we know this point, DCRP, it's a deformation. And this point we call DCRN. So it is DCRP minus 2dy. Okay? So it's very easy. So we use this relationship. So, okay? So return point to DCRP, negative side is DCRP, D minus 2dy. Okay? And the force is F, positive side, and negative side is F minus 2fy. And the new force is F plus SD multiply DD. So it means, and so we are now level 2, and we know this is going returning. Returning. Okay? So this slope is S. This slope is S. This is S or SC. Okay. And this is SC. Okay, okay. This stiffness is SC. SC. And this stiffness is SY. Okay. So, and this is DD, DD. And DD is negative. Okay. So we want to know the force of this point. This is F1. So this point F and this point D. Okay. So F1 is F multiply this thickness multiply DD. DD is negative, so it will go down. Okay. So F1 means F plus S multiply DD. So when you look at this one, I'm talking about this part. And the stiffness is now changed to the SC. And level is 4. Level is 4. And if you are negative side, second slope, it's the same. So if DD is positive, it means you will go back to, returning. So you jump to 310. If DD is negative, it continues to stay level 3. Okay? And okay. And the return point is actually left side of level 4. So it means the negative side. And the positive side is you add 2dy, dCRP, and the force is the same. Negative side force is F, this point. Okay? And you add 2Fy to get the positive side force. And force, new force will be this one. And the stiffness is SC, level is 4. Okay? Almost the same as this one. Okay? And the last part is level 4. You are now level 4. So you check deformation is over than dCRP positive side, or deformation is less than negative side, dCRN. So you check two equations. dy is greater than positive side, or this dy is less than negative side. So if you are positive side, it will go to upper side, upper slope, right? So you jump to 410. And because stiffness is changing, you must calculate force from this formula. Now you know the meaning of formula, I think, because it's same as I explained before. And very similar to this one. You are now level 4, and this is positive side, dCRP. And this part is dCRN. And your new deformation is go over. So you want to get, no. これ違うか。Sorry. I made a mistake. で、よいしょ。You are now level 4. you know level 4. And the positive side is BCRP. And the force of this FCRP. And the slope is going up this way. So what you need is you are before level 4, but the new deformation is D1 is over than BCRP. So you cannot continue like this. You must find out the new force. This point, this point, this point. So this is F1. So F1 is FCRP plus this increment, very small increment. So this deformation multiplies second slope SY. So F1 will be FCRP plus increment of deformation. So D1 minus BCRP multiply second slope stiffness. Yeah? So this will be new F1 in the second slope. Yeah? It was the same as yielding. Yielding, it was dy before, and this was fy before. But now it is FCRP and BCRP. So this formula. And the plastic deformation is also this second slope deformation. You add the BCMP, so it is including. And the negative side, same as this one. And the slope is SY. Okay. And that's all after all natural level, finally it will go to 1000 or 1000. So every step you will finally go to 1000. So this is the fourth increment. And maximum, so you compare current displacement compare with D max P. And if D max P is, the new deformation is greater than D max P, you adapt this new deformation as a D max P. And same as negative side, if new deformation is less than D max N, so you replace D max N to D1. So finally, D max P will be positive maximum, D max N is negative maximum. Zafira-san, do you understand? How do you think?
Okay, sensei.
Okay. How about Ahmed-san?
Yes, sensei.
Yes?
Yeah.
Well, please read it again and please understand correctly, perfectly. But the procedure is the same. And I don't know Python code how to, maybe Python also has a go-to command. I don't know. And well, definitely they have if command. So
Can try.
please
Yes, for F, yeah, it has it for me.
convert this code. If you ChatGPT, maybe you can, ChatGPT may convert automatically. But I recommend it to yourself. Any question? No?
Okay, sensei.
Okay. So good luck. And next meeting is next year, right?
Yes, 先生。
So I hope you can show me Python code.
OK、先生。
じゃあ、終わります。OK, see
あり
you.
がとうございます。